let's get the derivative of arctangent of cotangent x. So in here, since we have a function of inverse tangent, and inside of inverse tangent, we have another function in which it's a trigonometric function, which is cotangent of cotangent function. Now, in here, the question is how are we going to get the derivative? So since our main function is inverse tangent, then that means it has something to do in terms of getting the derivative of inverse tangent or arctangent. So there are two formulas, but one of them is actually applicable in this problem. I'll show you. So we have two rules of differentiation in terms of getting the derivative of inverse tangent. One is this one. If you take a look closely, the derivative of arctangent of x is just 1 all over 1 plus x squared. On the other hand, it's just the same as on the first one, but with chain rule. So that means we have arctangent of u is equal to 1 all over 1 plus u squared times the derivative of u or du all over dx. So which one are we going to use? So uh, the answer for that question is this one. We're going to use this one. Why though? Was it because there is like a trigonometric function inside of your inverse tangent function? Yes. All right. The thing is, this function here is an example of composite function. Remember, a composite function is what? Okay. Let's just say we have f of x and g of x. And then imagine that we have a function of f, but we will replace x with g of x. So we will have f of g of x. So what does that mean? It means that there is a function g inside of function f. So likewise in this problem, there is a trigonometric function inside of inverse tangent function. So this is an example of composite function. So therefore, we will use chain rule of differentiation. And since we have inverse tangent function, so we will use this formula with chain rule. All right? So let's get the derivative of this one. So we have this one. What are we going to do? First step is we must substitute u as the inside of inverse tangent. Since the inside of inverse tangent is cotangent, we will let u as cotangent x. Alright? Then after that, we will get its derivative. But basically, let's find du all over dx. So du all over dx, the derivative of cotangent x is cosecant squared x. Remember that the derivative of cotangent x is just simply as negative cosecant squared x, right? So now what are we going to do? Since we let u as cotangent x, we will go back here in this function and we will substitute cotangent x as u. So this would become y is equal to arctangent of u. Then after that, we can now get the derivative of it. All right, so what's the derivative of arctangent of u? It's this one. So we will have 1 all over 1 plus u squared times du all over dx. All right, then after that, let's bring back your letter u and substitute du all over dx. Remember that our u is cotangent x. So we will have 1 plus the square of cotangent x. Right, that's it. Wait, let me just fix this one. Right, there we go. All right, that's it. Times du all over dx, or the derivative of u, which is negative cosecant squared x. All right. Then let's combine them together. Let me just put the solution here so that we can occupy more space. So y prime is equal to, so this would be 1 all over 1 plus the square of cotangent x times negative cosecant squared x, we will have negative cosecant squared x all over 1 plus the square of cotangent x is just the same as cotangent squared x, right? This is just the same as this, right? So here, we can actually leave our answer, right? This is our answer. Or we can still simplify this actually, all right? You see the expression below, the 1 plus cotangent squared of x, you see that? Let's recall a lesson from trigonometry. Okay, this is according to Pythagorean identity. All right. So in Pythagorean identity, 1 plus cotangent squared of x is just the same as cosecant squared of x. I repeat, 1 plus cotangent squared x is just the same as cosecant squared x. This is according to Pythagorean identity, which is part of trigonometric lesson. So, we can substitute 1 plus cotangent squared of x as cosecant squared x. Hence, this would become y prime is equal to negative cosecant squared x all over cosecant squared x. All right? Then we can simplify further. Negative cosecant squared x divided by cosecant squared x. This is just the same as negative 1. And that is our answer.